So it's kind of weird, but I did a quick bout of research to find out, okay, why are we all having the same experience if we put a USB drive in there? And evidently, you can use a plain USB for a security key. But there's a second step involved in the process. So first you need a plain USB drive, and then you need to use a USB security key app to store the encrypted key on the thumb drive before you insert it to set it up as a second factor. And I know that there are commercial security keys that you can purchase that already have this stuff pre-built. So if you go to Amazon and you say Windows USB security key, all sorts of pre-configured USB thumb drives, again, just plain thumb drives, but the creation and storage of the encryption identity is the encrypted identity is on there, and then you associate that with your login. And so that's easy to do, but you still can use a basic, yeah, and they come in all sorts of flavors with reinforced loops, right? So you can put them on key rings, and you know, UB is a famous brand for this kind of purpose, and they come in all shapes and interesting sizes. But the simple truth is, if you want to do it yourself, that's still possible. You simply download an app to create a USB security key, and then you use your USB drive to load the key onto the drive. And at that point, then you can be successful in terms of setting up the second factor. So when you go to accounts and then go to sign in options and security key, at that point, when you do this and you say manage, the little swirly circle will go further, and you're in good shape. So if any of you are interested in using a security key app to load a security key on your thumb drive and use that to demonstrate your two-factor, I will award additional credit, and you know, beyond the value of that item on your solution. Although if you're just interested in checking the box and getting it done for the two-factor part of your solution, all you have to do is pick one of your favorite accounts and configure a two-factor for it. My favorite one is my Gmail account. So inside settings, under security, I enabled two-factor, and it said, what do you want to use? And I used my smartphone. So there is an interesting wrinkle here, and I wanted to share this with you. This is the first time I've actually seen this. So you can remove passwords. So improved security, only allow Windows Hello sign-in. You can basically do some things more about sign-ins. So if you click on here and go to this, it'll actually say, as you keep reading, you're better off getting rid of passwords. So for the first time in history, Microsoft with Windows 11, and they may have done it in later versions of Windows 10, they're basically advocating removing the password altogether as an authentication mechanism. Okay. So that's a change. When you get rid of something you're not, if a device gets stolen or a password gets compromised, you're not in trouble. Of course, you have to have these other factors in order to be able to associate your login. Are there any questions about our security key interests for?
Nope.
Okay. Now, they're saying get rid of your password, but they still have a PIN option. And when you set up a PIN option, you can change the nature of a PIN so it's not just numbers, it's also letters, which for all intent and purposes is like a password all over again. So, except it's not, it has to do with your account used on this device, and that's separate from the security that you use for your Office 365 account in the cloud. So Microsoft is distinguishing between your presence as a user on your physical machine versus your presence as a user in the cloud in Office 365. And that can start to get just a bit confusing after a moment. Can you think of any questions that might be interesting to ask given the details we have just shared? Look at this one right here. Wow. That's pretty small, isn't it?
Yeah.
You would barely know it's there. I think that's the whole point, so that it doesn't stick out. Yeah.
Good question.
Yep.
So, for example, I use the Google Authenticator. I use that for the two-factor for my Gmail and other apps.
Yes.
Do you have any thoughts on that, or could that fulfill the assignment as well too?
That fulfills the assignment wonderfully. So,
Okay.
yeah, that's just a great way to do that. There's also a Microsoft Authenticator app that you can put on your smartphone and on your laptop, and so you can authenticate access to different devices from a different device. So they really want to try to
Is
get
there
away.
a better version? Is
Uh,
is either of them better, or both of them are the same?
I would say they're pretty similar in terms of how they work, and I've had decent success, except when my cellular service isn't that good, and then I have to connect to Wi-Fi, and that gets to be a pain. So, if you have the two-factor and you're not around Wi-Fi, it gets pretty frustrating. So that is one aspect of two-factor that you need to consider. Good question. Thank you for asking it. So, well, let's make sure we have. Did we capture everybody here? I think we did. Yeah, we did. Okay. What I'd like to do now is to just finish up our thoughts on chapter 1 slides. And I'd like to tell you that some of the details in the slides I do expect you to know for your assessment. I mean, this is additional material and it's a summary of what's in the chapter of the textbook. And it's convenient, right? And this is one table where I said you should spend some quality time on. Everybody remembers I called out table 1.3 explicitly, right? Yes?
Yes.
Okay, so it's a nice table because it shows CIA, right? Confidentiality, integrity, and availability. And then in that table, it has some basic information for hardware, software, the data files themselves, and when data is in motion. So when we say data, that's stored data. And when we say communication or networks, that's data in motion. Data at rest, data in motion. And that's a good way to look at data. Ones and zeros are ones and zeros. But when they're stored on a disk or a thumb drive or in memory, that's data at rest versus data in motion. Let me go ahead and bounce past this. We did call out a couple of terms on this slide in particular. And the most important ones I want you to understand Now, this psychological acceptability, does everybody see this?
Yeah.
So as a general security design principle, we talked about how it needed to be structured according to the acronym called KISS. Keep it simple, stupid, right? That's what KISS stands for. And the idea being that if security design is too complex, right? If it's not easy to use, it's going to create problems. So the idea of having open design that can be supported, that it's modular, that it's psychologically acceptable. You know, a 16 complex character password is psychologically daunting for too many people. Does that make sense?
Yeah.
Right.
Yeah.
So yeah, you can make things really secure, but the problem is, and we've always talked about defaults and how standard defaults are a problem. But this mention of fail-safe defaults, what they mean by this is you're going to want to have a plan B and a plan C. You're going to want to have other natural barriers in place. So another concept of security design principle is something called defense in depth. And if we haven't made specific mention of that yet, this is just one aspect that we're parsing out of what we see. The rest of these terms, I'm not so fixed on, but separation of privilege, least privilege, isolation, those are things that are really important. Now, attack surfaces. So we said footprints were another word for attack surfaces. And here you see different categories of attack surfaces, right? So you have a network footprint, you have a software footprint, you have the layer 8. Layer 7 is typically referred to in OSI as the application layer of networking. But layer 8 is the human being. So these are just more elegant ways of thinking of exposure footprints and breaking them down into more specific zones or domains. So you have exposures dealing with the user, with the applications, especially with the code, safe coding practices. A lot of times people are coding stuff, they copy and paste, and they don't know where the code is. So this chart in particular can be misleading if you're not careful about what it means, but the larger the attack surface area and the fewer layers of defenses. So when it says layering, we're talking about the depth and defense in depth, DID, layers of security. If you have deep layers, that means you have many layers, many levels of defense. If you have shallow layering, it means you have very few layers of defense. So there isn't very much depth in defense. The more you move in this direction and the more you move in this direction, the higher and higher the security risk is. Because you have a huge exposure and you don't have the defenses, okay? So that's what this chart means in particular. This is an example of an attack tree, which gets back to the kill chain we were talking about. And if you can figure out the steps that an attacker is taking and you can prevent or mitigate at any level, at any one of those levels, you prevent the attack. It's just good to have a diagram because in many cases, once you diagram exposures, people aren't immediately aware of some gaping wounds, right? So when you're talking about the security strategy, these are 4 domains of interest. Security strategy is like a security blueprint or a strategic plan for an entire organization. So the written standards that you have, how you implement them, what you do to check to make sure. In our last class, we asked you, how would you tell somebody really new not to insert a lost USB? What's the ultimate test or assurance that your people have learned not to insert a lost USB?
Then don't put it in.
Leave a lost USB in front of them and see if they stick it in their USB drive, in their port. That's the ultimate assurance. That's how you evaluate whether or not your training is effective and if they're getting it and if they take it seriously. Can everybody see ITU right here?
Yeah.
So ISO, when it says ISOC, the more common acronym is ISO. You have NIST standards for security. Those are federal, US federal. The National Institute of Standards and Technology is a division of the Department of Commerce. And this is really helpful stuff. So when you're looking at security design principles, the standards are important references to make sure that your design is complete. You haven't missed anything. There's an international version called ISO. This is an interesting one, ITU. So the ITU has to do with telecommunications providers or network providers. So this would be anybody that's a network company, internet service provider, cellular service, plain old telephone system. They're all members of the ITU. And there are security standards that are part of the United Nations, right? Has anyone ever heard of the United Nations?
Yeah.
Okay. So there are some really decent, oh, and here it says, all right, so the ISOC is a professional membership. That's different than the ISO. The ISO I was referring to earlier was down here. So that's the end of our chapter 1 overview. Are there any questions before we flip to chapter 3?
No, sir.
In your textbook in chapter 3, much of this has to do with authentication. So it's a deep dive into authentication. And you'll notice that I crossed out 4 and put 5 in here because the textbook needs to be updated a bit. So when you establish a user identity, that's what authentication is. This is the definition. So it would be good for you to know the basic definition about establishing confidence in the user identity so that when access is granted, you have the assurance that somebody's in there who's supposed to be in there. Of course, there's all kinds of layers of detail. The special, whenever you see SP, that's a NIST standard. So SP 800-171 is a standard provided by NIST, the federal guys, and it has to do with identification and authentication, or IAM, right? Same acronym. So the whole point is you're going to provide the means to identify information system users and processes acting on behalf of users or devices. When we say processes, we're talking about the services that are running once somebody's logged in. And then these are the extended concepts that come with that, right? So a lot of fancy diagrams. I don't expect you to know every diagram and be able to talk through every subtle nuance, but the basics are important. A person who is presenting for authentication is called a claimant, right? So let's say that again. When you are about to enter your password to gain access to a resource, you're a subscriber to the resource or a claimant in fancy terms, right? And if you're using tokens like a USB thumb drive, right? That token is created and there's a service provider that registers that identity token that's on the USB thumb drive, and then you are registered as the identity for that service. Now, this seems like a really complicated thing, but I want to use a practical example. Can everybody see this?
Yeah.
Yeah.
This is a certificate. So the padlock represents an encryption key that's embedded inside something we commonly call a certificate. A certificate is associated with a real identity when the root certificate is created at a certificate authority. So if Google creates a cert or a certificate that they want to use with all their stuff, like their web browser and their websites, then all of that depends on the back end for a single case where they approached a special company, right, for registration, where they proved they were actually Google. And then Google said, okay, here is your root certificate. And that became the basis for identity. So when people connect to Google resources, ultimately each of those certificates flows back to the root certificate. That's what this slide is talking about right here. So when if you have a certificate as a credential, right? It's the certificate authority or registration authority that connects who you are as a real person during user registration and identity proofing. So somebody had to show up from Google headquarters with proof, hey, I work for Google. And then that certificate was bonded or tied when it was registered. And now it can be used for identification purposes. Now that I'm oversimplifying here, but you see this kind of thing happening there's a similar process that plays over and over again. It's just there are different methods. When the subscriber or claimant has that certificate or that token and they want to get on a system, they pivot and now they're connecting to online systems. And those online systems are doing a comparison to the back end. See, that's what this dotted line is. So they're going to see the token and then they're going to compare what they know with the source. And the source is going to say, okay, they're good. That's an oversimplification of the diagram that explains NIST's standard for authentication process, but that's pretty much what it is. So you have a relying party, you have middlemen in between, right? It is possible to steal a token, and if somebody's stolen the token and they also know another factor of authentication, that's how they impersonate you. But they have to know this whole process. And there are safeguards, so if somebody gets a hold of your token, they have to know other pieces of information, like a real-time PIN code that changes every second and it's calculated randomly and it's beamed onto a little device that holds the PIN code. So you can't just plug in the token. You can't just plug in the USB. You also have to have a second device that's connected to the internet that receives, well, sometimes it isn't connected to the internet, but it has an algorithm that generates a PIN code, and on the back end, the same PIN code is on their screen, and you have to enter it in order to get in. So here they're saying 4 means of authenticating user identity are based on, right? And it said something the individual knows, something the individual possesses, something the individual is, and something the individual does. And in our study guide, we've actually explained there's a 5th, right? Which has to do with certificates. And so an individual or a website possesses an identity, and you see the word individual, 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 individual. When you're authenticating, it's important to understand that there are computer certificates that authenticate a computer's membership to a domain. And I think that's important to understand. Why is it important to understand? Hold on just a second. Were you in one of my classes when I was using the remote desktop connection?
Yep.
And it's asking me for my individual login credentials, but I'm connecting through a remote method. And when I hit connect, when I successfully put in this password, half the time it's going to ask about the certificate because the other system, the other computer wants my computer to authenticate, and it's going to ask about a certificate. Now this is showing its ugly head here. I'll have to check to see what's going on. Maybe I need to reboot my remote system, but normally when the screen pops up, there's a golden screen that asks about the certificate. And I just wanted you to be aware that authenticating a computer locally for remote connections is actually a thing. And that certificate is something the computer possesses, right? So it's like this second method of authentication, except we're not talking about a person, we're talking about a computer, okay? So I just explained, and this is my slide, the methods related are centered on user accounts. However, computer accounts need to authenticate in corporate and enterprise networks, and oftentimes a unique certificate based on the X.509 standard, right? Certificate is X.509 is the same standard that's used to create those computer certificates that are inside the web browser. So when you see this padlock, that's X.509. In Active Directory domains, in Linux realms, and in other environments where 802.1x standards are required. So this has to do with authentication of network clients. And I didn't want you to think that it was all about people and users all the time. Sometimes it's about computers. Any questions about this? Okay, so what you see here ties in with our classical, if you remember Intro to Cyber, we talked about risk assessment. And one of the things that you want to understand is how great is the risk compared to the access if someone else that's unauthorized can get in there. So there are 3 different components that tie into risk assessment for user authentication. This is just good information to know. but the potential for impact, the areas of risk, and the assurance level. Now, multi-factor authentication, is two-factor authentication or more than two factors, right? So you don't just have two factors, you can have more than one factor, a third factor, a fourth factor, a fifth factor. It's always good to identify. And in some cases, authentication criteria can include things like GPS location, right? So if you're logging in, but it expects that the client that's connecting is from, I think we've covered this before. Does that ring a bell? Yes, no, maybe?
I don't recall.
Okay. Well, there in your study guide, I think there is mention of other factors that can be used to authenticate someone. And so your GPS identity, if you're in the Virgin Islands and your GPS shows that it's China, then there's obviously something wrong. So even though the password is correct, if the GPS location isn't good, it'll fail. It has to pass more than one authentication factor. So when we talk about assurance levels, the authors describe 4 different levels of assurance, and they're talking about verifying a person's identity, okay? So with respect to authentication, level 1 means there's little or no confidence in the person's identity. And the reason you want to identify assurance level, you want to make an intentional decision about how easy it is to give someone access. If what you have online is for the general public, and as long as they're not a hacker, and these are local people, you could say, oh, okay, as long as their GPS is from the Virgin Islands, and that can be faked, but if that's the only factor, would be a good example of a level 1 where you don't really know who it is, you just are sure that it's someone from the Virgin Islands, right? So it's a basic level of assurance about their identity. Level 2, some confidence in the asserted identity. Level 3, high confidence, and then level 4, very high. So if the GPS matches, then the known password is good, then the UPS token works, then their fingerprint or retina scan. That would be that's the kind of stuff that you would need level 4 for. Cases where somebody in an extreme position of authority, like the governor of the territory or the president of the United States, we would want level 4 assurance if they were signing on to get access to release nuclear weapons using the codes. Does everybody understand that?
Yeah.
So you'd want level 4 assurance. They have to have an extreme degree of confidence. The president is the only one that can say, okay, we're going to have to use nukes because we're in a bad place. All of a sudden, Russia has turned on us and they've sent nuclear weapons, and unless we pay them back, nothing will exist of the United States of America. Impact levels are defined in a federal document called FIPS. So FIPS has to do with information security, and 199 defines the 3 levels of potential impact for organizations. And it's just good to have an idea. If you're trying to protect an asset that has a low impact, then what kind of assurance do you need? Well, if it's a low impact, you don't need a level 4 assurance, right? So the impact and assurance are 2 measures of how serious you have to be. An authentication error could be expected to have a severe or catastrophic adverse effect. The potential of somebody impersonating the president of the United States and releasing nuclear weapons, that is bad. And the potential impact is hard to measure, right? So this is our author's way of framing how you balance those interests. the level of assurance, the impact factor, right? You can kind of cross-reference those like we did that previous diagram. And you end up with some combinations where the interest is very, very high. So the potential impact and the assurance level are extreme. And here you notice civil or criminal violations very high, right? Loss, financial loss or organization liability, right? These are pretty high impact levels and assurance levels, commensurate insurance levels. Passwords are standard. We want to spend a little time before our class is over talking about all the different things that are problematic with passwords and how to protect them better. So they're widely used and they've been used for decades. And it's used in combination with a user ID. The user ID is the label associated with the user account. So the user account is a virtual object. It's a logical object inside a system. And the user ID is the label that's on that object. So in my case, it's my first initial and last name. And that's a standard practice to use the first initial and last name. That's the user ID. But that's only half of the authentication credential. The credential itself in combination with a user ID usually is paired with a password. That's the practice. So you don't really have a login credential proper until you have a way to authenticate the user. One thing that I say over and over again is that using plain identities for users it's problematic, because if everybody knows, well, it's their first initial and last name, and then they identify you on Facebook, they have half of what they need to access your system, right? But if you had a user ID that had nothing to do with your name, that would be much harder to guess. So this is a great diagram of all the different things that can exploit passwords. There's something called an offline dictionary attack, where they look for the hashed values of common passwords. For a specific account attack, they'll use popular passwords to try to brute force or enter them over and over again. Just guess popular passwords, right? Against a single user. So you see all of these components together. One thing we can do is monitor electronically the network, because if you don't have a padlock on the website and you're connected with Wi-Fi, here I have a padlock. So I have TLS, which is called Transport Layer Security, right? And this protects information that's entered on a website. But if you don't have a padlock and you're connected with Wi-Fi, the stuff that you type in can be plainly read. And that's a huge problem. In fact, I want to repeat that again. If you have a website that isn't encrypted and it doesn't have a padlock, TLS, used to be called SSL. So you may have heard the term SSL. SSL has been retired because it's been hacked. The technology is now called, its replacement technology is now called TLS. And if you don't have a way to encrypt website access and you're on a Wi-Fi network, somebody can read your passwords in the clear just by capturing what's in the Wi-Fi cloud. Okay? So one of our important aspects, and I think we've already covered this previously, but in chapter 3 in your textbook, it says, hey, we want you to be able to explain how hashed passwords are used for user authentication. True or false? We send passwords across the network when people are authenticating across the network. True or false?
True.
That is false. If we sent the passwords across the network and somebody was listening or monitoring the network, they could capture the password. What we do is we use encryption to create a hash. That's an encrypted value of the password. So we put the password that somebody types into an algorithm and out pops a hash, what's called a hash. It's an encrypted value based on the password that was entered. That encrypted value is compared to the encrypted value on the server. So all they're doing is comparing encrypted values from this side to that side. No passwords ever travel the network in the clear. Any questions about how passwords travel?
Nope.
So you have a password, then a hash is created. You can actually randomize the hash and make it harder to reverse engineer or reverse lookup by including something called a salt. It's a random extra value that's inputted into the algorithm. So you have this hash, and on the other end, they have the identical way of generating that output, and they compare the outputs. So they compare the encrypted value, but the encrypted value can't be traced back to the original value in the clear. The clear text, you can't, one thing about a hash is that you can't decrypt it. A hash is a special kind of crypto algorithm. You cannot decrypt it to get the clear text back. That's what makes hashing so special. It's a one-way encryption algorithm. The only thing you get is the encrypted value. If you take the encrypted value and you try to reverse it, you don't get the original input, ever. So then they take the same hash algorithm and they take the same input and they compare the two values. So there's lots of extra finer points about back in the day, 30 years ago, when they had Unix systems, long before they had Windows or Linux, how they secured systems, and they used a standard called DES. So that is that was the standard for encryption. Now they've replaced it with AES. So DES stands for Digital Encryption Standard. And about 20 years ago, a French graduate student with 6 PCs installed Linux and had them clustered as a Beowulf server cluster. And I think in so many weeks or months, he cracked the encryption. So he was able to break it. So now we use AES, Advanced Encryption. The important thing to remember is that the first encryption standard, DES, was used 25, 30 years ago with old, large systems. And now we have something that's much more advanced. It's called the Advanced Encryption Standard, AES. And so far, it takes nothing less than a supercomputer and a nation state to, and an awful lot of time to try to decrypt something. MD5 is a popular hash. It's 48 bits. The algorithm is 48 bits. And essentially, MD5 was blown up along about 20 years ago. MD5 was, the term is deprecated. When something is deprecated, that means it's retired because it doesn't work anymore. Now, OpenBSD is a type of Unix, and it had an encryption algorithm called Blowfish that used 128 bits with a 192-bit hash value, and it was actually really secure compared to the previous hash standards. But just remember that MD5 was one of the original. It's still used just to get a quick integrity verification to see if something has changed. These are the 4 common password cracking methods. This is the slide I want you to pay the most attention to. It is slide number 20 of 54. I want you to know something about each of the password cracking methods. John the Ripper is a utility. So you download and install John the Ripper as an application, and then it helps you crack passwords. There are other password crackers that exploit the fact that people choose easy to guess passwords, right? Dictionary attack is a large dictionary of possible passwords and to try each against the password file. So they do a survey and find out how many common passwords are they. Here are the 100 top most common. Let's run down the dictionary and try to enter the first 100, right? Rainbow table we mentioned. It's huge. Mammoth is the term. That's what they're using, mammoth. We calculate the hashes in advance, and then we calculate the hashes for what we've captured from the user, and then we compare the hashes, and then we find out what the input was that did it. So it's a reverse lookup. Another word for rainbow table is reverse lookup. Are there any questions that come to mind about password cracking before we finish our class today?
No, sir.
Okay.
Wait, so you're saying it's impossible? It's impossible to crack the AES?
I'm saying that it takes a ginormous amount of resources, and it's not likely for the average hacker to do. No. Yes. That's what we're saying. But it takes, if you have a nation state, like, and by nation state, I mean country, you know, the country of France, they have supercomputers. And if they want to read their enemy's stuff, they could use their supercomputers and might get somewhere sooner. Does that help answer your question?
Yes.
Good. Now, other things that you want to know about, there are finer points about password policies, how to make them stronger. These are the modern approaches. It's good to know this information, and you might have, there may be an item or two in the assessment about this. Most of the concepts you need to know are in the study guide, but this extra information in here might be used in one of those items. So here you see just a chart of how easy it is to guess passwords if they're common passwords. And so they've actually studied this thing quite a bit. Having the passwords, the encrypted values for the passwords stored, that's called a password file. So the password file doesn't store the actual password. It only stores the hash. And essentially, this is kind of a gold mine for hackers. If they know where your password file is, they can make quicker work out of cracking the passwords. And understanding that a password file and how to control access is important. This is one of those very sensitive files on a system you want to protect. So you want to be sure that when you change the permission, you can change or improve or strengthen the permissions for who and what accesses this file, right? Any questions about the password file and protecting the password file?
No.
All right, so again, best practices for how to use stronger or create stronger passwords. That's what this information is about. You can get a computer to generate passwords, or you can educate users how to do something that's really hard to guess. One very simple technique is to take the first letter of a favorite song. Somebody give me the words of a favorite song.
Tally.
Tequila.
Say again.
Tally.
Okay, those are the words of the That's the words of a song.
Yeah, tally, Tally.
Tally. Tally. So that's the word of a song. Okay. Well, if you have the words of a phrase, does everybody know what this is? Has anyone ever seen this on a t-shirt?
Yeah, don't pay me no mind.
Right. So that's a common phrase. But what you could do is you could basically take the second letter of each, like O for don't, A for pay, E for me, O for no, I for mind, and then add a number to it, like 1, because I shifted those numbers in the words 1 character, right? That's a good way to do it. I like using words like scriptures, and I have a file, I call the scripture file, right? But I create passwords based on famous Bible verses. And so I take the first letter of, here's a good one. The Lord is my shepherd. I shall not want, right? So that's a complex thing. Now, if I change some of the numbers into some of the letters into numbers, like every time I have the word two or the number two, the word two, I can substitute it with the number two. And if I do this enough, I'm using something called leet speak. Has anyone ever heard of leet speak before?
Nope, never.
Yeah.
So leet speak, it's a shortened version of the word elite. And what you're doing is substituting certain numbers for certain letters. Like instead of an E, you put a 3. Instead of an O, you put a 0, right? So if you did this and you said, this is the default password for you can tell what that actually was originally, right? That's leet speak. So a lot of password crackers know that users like to try to spell common words with leet speak. That's not as strong as taking the first or second letter of your favorite words in a sentence or a phrase. The popular song, Bible verse, children's rhyme, it could be anything. But those are much harder to guess. Okay, so what we'll do here is close out our session. I'd like you to finish going ahead and looking at the rest of the slides, right? So we've talked about Bloom filters before and what they are and how they work. This is just additional information with what you already have in the study guide, but make sure you go over these things, smart cards, memory cards, right? These are authentication methods. I'm sure there's something in here about biometrics and how biometrics can be a problem. Yes, biometrics, how those can be problematic, but it gives you the different versions of them. And then what you want is a certain amount of error. So that's why one thing about biometrics, they make you put your finger. Have you ever noticed you got to put your finger on there 10 times? They're reducing the error rate and getting a good read on the different ridges and grooves in your fingerprint. And so there's an important metric in here about how biometrics works, yes or no. And it has to do with the algorithms. The important thing to remember about biometrics is that they're not fail-proof, right? They're not perfect. And what you want is a high degree of confidence for repeated entries. And there's actually a specific term for that. It's in here. Okay. I wish you luck on your first attempt of the Module 1 assessment. If you have any other questions about the material as you finish reviewing, don't hesitate to contact me.
All right, no problem. We'll do.